Hello everyone, greetings from CADD International. Today I welcome every one of you to our Renaissance program of the month, October. As we all know, Renaissance is the program to showcase the talents of our students. Today we are going to share the project presentation of our students from the software Revit structure. Before getting into the presentation, I would like to congratulate our trainer, Mr. Midhun Das M, for his great efforts. Let me introduce our students who are going to present today. They are Maurya AY, Sohan Jain, Sanji Soni and Ramachandra Bhagavan Mulik. Let's start the presentation with Maurya AY. Over to you, Maurya, you can start.
Hi, myself Maurya. I'm doing my civil engineering at Bangalore Institute of Technology. I have taken Revit structure course at CADD International. Really, it was a great experience. I learned many things under the guidance of Midhun sir. Today I'm presenting my structure project. Here you can see the 3D view and analytical view together in a single sheet. This is the analytical view. I have shown two analytical views together in a single sheet. This is the 3D view. This is the plan view. I have shown the plan view along with the dimensions of the frames that I have used in this project. This is the section view and another section view. Here I have shown the section of footing, stairs along with the rebar. This is the east elevation, north elevation, south elevation and west elevation view. Here I have shown the schedule. This is the scheduling. Bar diameter, bend diameter, etc. I have shown here. This is the warehouse. It's a structural steel structure. Here I have shown connections. Connection between footing and column. Connection between column and beam. Connection between beam and beam. And coping between column and beam. And the scheduling part of that, the material that I have used, type of material and their family, cut length, etc. I have shown here. Thank you.
Thank you, Maurya. That was a good presentation and congratulations for you. And for next we have Sohan Jain. Over to you, Sohan. You can start.
Hi, this is Sohan here. I'm studying BE in Civil Engineering. I designed a residential villa in Revit. So finally, I'm come to present of my project. So let's move on to the project. Residential villa G+1. This is the 3D view of the villa design. And it is the analytical model of the villa. And it is the foundation plan. Mentioned everything, dimension, center line, dimension. And it is the foundation 3D view. And it is the foundation plan 3D view with rebar. And it is the ground floor structural slab level. Ground floor structural slab level 3D view. Ground floor structural slab level rebar 3D view. First floor structural slab level plan, and it is the 3D view. It is the rebar 3D view. And it is the terrace structural slab level plan. It is the 3D view. And 3D view of the rebar. This is the headroom of the terrace. And finally, we come to the complete 3D view of the villa. And it is the complete 3D view how we actually design rebar, everything. In totally detail. And it is the south elevation, north elevation, east elevation, west elevation. And we did a rebar schedule. I did 3 parts. The diameter of the rebar. This is the 10 mm rebar schedule. We mentioned what we need, everything, what we need. This is the 14 mm rebar schedule. I also calculated total cost. This is the 16 mm rebar schedule. And this is the structural foundation schedule. And totally 15 counts of footings. Structural material M25 concrete mentioned. Structural column schedule. This is structural framing schedule. The rest on this particular schedule. This is above the terrace framing. So thank you.
It was Sohan who completed his presentation. It was a great work, Sohan. Thank you for your presentation. And for next we have Sanji Sodi. You can start, Sanji.
Hi, my name is Sanji Kumar. I am a civil engineer by profession and I am from Chandigarh. Today I am going to present my Revit structure project that I had made under the guidance of Mr. Midhun Das. I have planned a ground plus one floor frame structure. The total covered area for one floor is 2052 and 0.20 square foot. At the ground floor, I have provided 2 bedrooms, one dining area and a study area. And here we have kitchen as well. And I have provided a front yard and a car park as well. This is the stairs of the building and this is the open area. And here I have provided some sitting arrangements as well. And for the first floor we have 2 bedrooms. This dining room I have converted it into bedroom, and here I have provided a toilet, and this porch area I have converted it into office area, and this kitchen, this I have converted as a store. Now talking about the structure, I have designed this building using CADD software. For the same, I have used YouTube videos as a reference. Talking about the slab of the building, I have designed it manually as a two-way continuous slab, and the load of that slab, I have taken that account into the CADD software. These are the calculation of the two-way slab that I have designed. Now coming back to my project, the first sheet here is split slab detail, and or you can say grade slab at ground floor level. So the thickness of the grade slab is 150 mm. Here I have provided 8 mm dia bars at a spacing of 300 mm center to center, and these are the bottom bars which I represented by this. And this is the 8 mm dia bar, 300 mm spacing, and these are along y direction. And same, in order to represent bars along x direction, I have used this arrow mark, and these are the 8 mm dia bars at the rate 300 mm center to center in x direction. Likewise, for the top mesh, I have provided 8 mm dia bar at the rate of 300 mm spacing in both directions. To represent the bars in this manner, I have used aligned multi-bar annotation option. To represent this top bar, I have used aligned dimension, in which I have replaced a numeric value into text value. Now this is the plinth beam framing ground. The size of the plinth beam is 230 by 380 mm. To show name and location of plinth beam, again I have used align dimension option. Now, in order to represent the reinforcement detail, I have cut down longitudinal section of all the beams to show through beams, through bars, extra bars, and shear reinforcement in the form of stirrup. This is the detail of plinth beam 01 from grid A to H. At the bottom there are two number 16 mm dia bars, and at the top we have two numbers 12 mm dia bars. To represent this number of bars and dia of bars, I have used tag bar category option. To write L by 3, again I have used align dimension. Likewise, details of other beams are given in this sheet. These are the detail of other beams, and as well as this is the another sheet for plinth beam detailing. Now coming back, this is typical floor framing plan, and again I have used a line dimension in order to represent name of the beam. Now, for example, this is beam 12, and now I'm going to represent detail of beam 12. Detail means reinforcement detail of beam 12. So this is the section of beam. This is the section of beam 12, longitudinal section of beam 12. Here I have provided two numbers 12 mm dia bars at the bottom, two numbers 12 mm dia bars at the top, and the shear reinforcement are 12 mm dia bar which are 32 in total, and they are provided at a spacing of 130 mm center to center. Now, in the next sheet, in the next sheet, in this sheet, we have typical floor two-way slab. This is the this is the 3D view and plan view of the slab, and I tagged this slab as S1, and likewise wherever I have provided two-way slab, I have tagged it as S1 because this span and this span will follow the detail of as per this slab. In S1, we have main bars along y direction, which is 50% bars are benter bars. These are the benter bars, and rest are straight bar. These are the straight bar along y direction. And more detail are given in the section view of the slab, and same we have in the y direction. So this is the sectional sectional view in section of the slab in x direction. Here the thickness of the slab is 150 mm. First, there are benter bars along x direction, that is 8 mm dia bar at the rate 230 mm center to center. The arrangement of laying crank is that crank is provided at L by 4 L by 4 from the center, and it would continue till the next span. It would continue till the next span, uh, till the distance of L by 3 of the next span. And wherever there is a fixed support like this, we have to provide benter bars at a distance of 0.15 into length of that span. These detailings are as per the IS 456 code. Then in this X section, we have 8 mm dia bars which are provided at the rate of 230 mm center to center. These are the straight bars, and we have to provide this straight bars from center of this support to center of this support, and when the next span will come, this will be from center of this support to the center of uh, to the next support span, next support of the beam. Then along y direction, this is along y direction, we have straight bar and benter bars at the rate 200 mm center to center. They are 30 numbers in total. Where 15 numbers are benter bars, these are the benter bars, and 15 numbers are straight bars. And for the rest of the span, we have to follow this. We have to follow the same specification. In the next sheet, we have typical slab detail of typical floor slab. Here, this is S1, this is S1, this is S1, and again, this is S1, this is S1. We have to follow the same method that or the bar arrangement will be same as we have provided in this span according to our design. Now, this is our S2 span. Now, this S2 span, the thickness of this span is also 150 mm. Here I have provided 8 mm dia bars at 150 mm center to center in both direction, and as well as for top and bottom bars. This is basically a double mesh. Now this is S2 and this is S3. S3 is basically for the sunken slab S3. Now talking about the detail of the S3, uh, the thickness of the slab here is 150 mm and it is a sunken slab. Here we have bottom main bar, we have bottom bars at the rate 200 mm center to center, and the dia of the bar here is 8 mm. Here the total number of bars are 9 numbers. Then the distribution bars are also 8 mm at the rate 200 center to center, and likewise uh, the top mask, for the top mask we have same sort of bar arrangement. So this is the sheet which represents the rest of the span, which are S2 and S3. And in this plan I have mentioned which is the span S1 and which is the span S2. And here I have shown the bar arrangement along this passage area, and this is my open area, this is my stair area. Here I have made some changes in the laying of the bar, and I have mentioned here as well how we are going to lay our bars in this passage area. Uh, Now in the next sheet, this is my typical column detail. The size of the column is 230 by 300 mm. Uh, Now for each column I have provided 4 number dia 12 mm dia bars, longitudinal bars with a development length of 300 mm at the bottom and at the top as well, where the my floor slab has ended up. Now talking about the stirrup of that stirrup for that column, I have provided 12 mm dia bars at the rate 100 mm center to center from the footing level to the plinth level. And for the rest of the typical floors, the spacing of this stirrup is 190 mm center to center. This is the design this bar arrangement has been provided by the CADD Pro analysis. Now my next sheet is about footing. This is the footing plan of my building. I have used again I have used tag system in order to tag the footing name. This is F1, F2. This CF2 are the combined footing of this building. This is the structural foundation schedule that I have generated using the schedule option. So basically this is the scheduling of our footing, and this is the length, width, thickness, and now the total volume of concrete of the footing. Now in the next sheet, this is the detail of footing along grid F1. I have cut through a section. I have cutted a section through I grade, and these are the all footing that comes under the grade base grade. Example, footing F2. So this is my I grade, and these all footing F2, F19, and F13, F22. This comes under the grade I, and this is the section of this footing. I have drawn this section in order to represent reinforcement detail which I have used in footing. So here we have 10 mm dia bottom bars, at the rate 75 mm center to center. Then we have 45 numbers 10 mm dia at the rate 70 mm center to center. These are the main bars and these are the distribution bars. And likewise for the top mesh we have this and we have this. Here we have 90 numbers. I have also represented the total numbers of bars which we are going to use in a particular direction. So likewise we have details of other footing. This is footing F19, F13 and F20 and this is the detail of all of the other footing that we have in this structure. Now this is the layout plan of combined footing along the corresponding axis. This I have drawn so that when at the time of layout of the building or the layout of that combined foundation, the mason would they will not have any kind of difficulty in order to plot this footing at the ground. Now the next sheet in this next sheet is our this is the plan of our stair. So here this is the plan of our stair. This stair has a riser of 176.30 mm and here I have provided a tread of 280 mm. This is the open area that I have shown in the AutoCAD file. Now I am going to represent my reinforcement detail for this stair. This is the reinforcement detail of first slide. This is this is wall for stair which is on the footing CF2. Here we have 16 mm. Here we have 16 mm dia bars that coming out from the footing along both faces of the stair wall and this both faces and the arrangement is as per the detail shown here. So this is coming out from this footing and this bar is going like this till the first slide or the first landing. And at the flight level or you can say first flight here I have provided this. I have provided 8 mm dia bars at the rate of 100 mm center to center as a distribution bar in the flight slab. So this is the detail of that distribution scale. So 1, 2, 3 and the total number of bars here is 9 numbers. Now this is the detail of my second floor slab. Sorry, second flight detail. Again main bars here are I have provided 12 mm dia bars at the rate 100 mm center to center and this and this how I have represented it here. And again these are the 8 mm dia bar distribution bar. This is the representation of this distribution bar. These are total 35 numbers and they are at the spacing of 100 mm center to center. Steel details at second landing are bottom bars. These are the bottom bars at 12 mm dia at the rate 100 mm center to center, which goes like this as I have shown in the section. Distribution are also same and it would go towards third flight. This is the detail of our third flight and here this steel is meeting up with that passage area slab that I had shown here. This is the passage area slab and this is the third flight. This third flight, here in the third flight I have to provide my reinforcement like stair reinforcement like this arrangement. Now in the next sheet, yep, in the next sheet here, this is the structure steel detailing. This numpty of the building, here I have used steel structure and steel columns are resting over existing concrete column of the building. So this is the existing column and this is the steel column that I have placed over this column. And likewise, below this column we have this concrete. Below this steel column we have this concrete and same in other beams. There are one or two columns where there isn't any there isn't any concrete column below that steel column. So this is the universal beam attached with column, and for purlins I have used hollow section bars. These are the purlins. For this I have used hollow section bars. Now in order to draw this wall and roof, I have used curtain wall system. I do not assign any specific material for both wall and roof. By using override graphic in view and the subject category, by category I have made transparency level to 60% of that for that slab, uh, so that steel structure could be made visible for everyone who is looking at this drawing. In the next sheet, these are the structural connections that I have provided. These are the column connection. These are apex connection. This is the column and beam connection, or you can say here we have steel column, beam, and a concrete column. And this base plate I have used in order to connect this steel column. Base plate I have made manually by the plate option, and the thickness of the plate is 30 mm. For bolt option, I have used this holding bolt down. Again, I have used the anchor option here in the Revit. I have used bolt option and I have used anchors for the arrangement of this bolt. Then in the next sheet we have this is my east view of the building, north view, south view, west view. So these are the different views of the building. So this is a 3D model of my building. Oh, sorry. This is the 3D model of my building. So these are the stairs and these are the footings. These are combined footings. And this is the stair wall which is coming out from the footing for in order to give a foundation for my stairs. This is the rendered view of the building. This is typical column layout plan. Here I have shown the arrangement of the column and what is the distance from the grids, so that anybody who is doing the layout of the building, easily he could easily lay down the columns onto the ground. Now finally, this is the analytic model of my building. So the whole experience was really amazing. As always, Midhun sir's teaching style that is entirely practically based had given us so much to learn about this Revit structure course. And because of him, I am able to prepare this project. Thanks Midhun sir. Thanks CAD International for the great learning experience. Thank you.
Thank you, Sanjeev Soni. It was a nice presentation. Finally, we have Ramachandra Bhagavan Mulik. You can start, Mulik.
Hi everyone, I have done two small projects. This is a structural steel warehouse and second is structural cordon shops. First is a structural steel warehouse. Structural steel to steel connection details are created. Angle clips, base plates are used in connections. Second project cordon shops. Height of the project's level has been doubled. The mount R has been added to the ports. Slabs, staircase, step footing, foundations are reinforcement, as well as I built an ellipse wall, water tanks with the roof levels. The added data is reinforcement to the ellipse walls. This is the sections. Thank you.
Thank you, Mr. Mulik, for your presentation. With that, we came to an end of the session. And finally, I would like to thank every participant of today and also our dear trainer, Mr. Midhun Das for his guidance. And wishing you all viewers a great day ahead. Thank you all.